Our next topic is forces. This is a physics GCSE topic, and I have referenced all the information from my school textbook. Don't forget to like, share and subscribe my channel and this video. Now let's start. What are forces? Forces are a push or a pull, which are measured with a Newton meter, and the unit is newtons. So forces either make things or objects accelerate, which changes their velocity, or change their shape. Next is resultant forces. A resultant force is a single force and tells you the effect of every force on that object. Did you understand anything? Me neither. So I'll try to explain in detail with an example. Now let's look at an example for resultant force. Here we can see a car that has broken down in the middle of the road. Now there's one man putting force on the car, but that's not enough to move the car. He brings another person, a bigger, more force. It's still not enough, so they bring more force, which finally pushes the car. So forces pointing in the same direction add together. The resultant force will point in the direction the most force did. If there is a resultant force, the object will accelerate or get faster in that direction. Balanced forces. First, let's see an example. The man on the left is pushing a box with 10 newtons. The man on the right is also pushing the box with 10 newtons. The box would remain stationary, so the object doesn't move. If the forces in opposite directions are the same, then they are balanced forces. There is zero resultant force and the motion of the object, so how it's moving, doesn't change. Now let's talk about Newton's first law, which states that if the resultant force on an object is zero, so if the forces are balanced, then the acceleration of the object will be zero, and the object will have a steady velocity. So, as an example, if a car is not moving, it will remain stationary until a force acts upon it. Next on our list, we have Newton's second law. This is an equation that shows how forces affect the acceleration, which is force equals mass times acceleration. The force in this equation is a resultant force. Now, let's go through an application of Newton's second law. So, we're using the equation, acceleration is force over mass, because that's Newton's second law. So here we can see a man pushing a trolley, so he's putting force on the trolley, with a bit of mass, so the acceleration increases. On the right, we can see the man pushing the same amount of force, but now there's more mass, so the acceleration decreases. This tells us that a bigger force makes the acceleration higher. It also tells us that the bigger mass makes the acceleration lower. This is why sports cars have powerful engines in order to get a bigger force, all while being as light as possible so that they have a lower mass. Let us see how this law can be applied in real life. In this short clip or video, we can see a Tesla Model 3 being smashed into the side of what seems like a concrete or metal slab. As you can see, the side of the car is completely broken. This explains why a car crash is so dangerous. When the car stops very suddenly, there's a very quick change in velocity, a big acceleration. This means you get a huge force on your body, which causes damage. Next, we will talk about Newton's third law, which says that every force has an equal and opposite force. So for example, if you push a wall with 200 newtons, the wall pushes you back with 200 newtons. This force stops you going through the wall. Another thing I want to touch on is terminal velocity. Let's look at the definition for terminal velocity. When you drop an object, it will get faster. This is because the weight that pulls down is the biggest force. So here we can see a man, and obviously the biggest force is the gravity pulling him down towards Earth. There is still some force that is trying to keep him up, and that's the air resistance that's hitting him while he's falling down. As the object gets faster, it will experience more air resistance. Eventually, the air resistance will be equal to the weight and the forces will be balanced. All this means that the object, or person in this case, stops accelerating and falls at a steady speed. At this point, the skydiver will be falling with terminal velocity. Thank you for watching this video. I really hope it helped with your studies and your exams. Please don't forget to like this video, share it to anybody else who might need help with physics, and subscribe to my channel. This is Isan K, Think Talk, signing out.